Hey everyone, welcome back to the next part of our Whiteboard app series. Today we are taking a big step forward. I will be creating a brand new Kotlin multi-platform project. We will take everything we have built in the first three videos, adapt it and make it usable for KMP so that our app can run on both desktop and Android. By the end, we will have the foundation for a truly cross platform whiteboard app. Before we jump into the code, let me give you a quick overview of Kotlin Multiplatform and Compose Multiplatform and why they are perfect for this project. Kotlin Multiplatform KMP is a powerful feature of Kotlin that allows us to write code once and share it across multiple platforms like Android, iOS, desktop, and even the web. In our case, we are going to use KMP to build both an Android and a desktop version of our whiteboard app. The key benefit here is that we don't need to duplicate code, especially the business logic or core app functionality. Instead, we can write it once and use it on both platforms. This means faster development, fewer bugs, and a unified code base that's easier to maintain. Next, we have this Compose multi-platform. It is an extension of Jetpack Compose, which we have been using for Android UI development. What's great about Compose multi-platform is that it allows us to use the same declarative UI framework for both Android and desktop apps. This means the UI components we have been working on can be reused, and with a few changes, we will be able to create a native desktop interface as well. Compose is still in alpha for the web, so we won't target web for now. But for Android and desktop, it's a fantastic tool. So to start developing the app using KMP, first what we need is the Kotlin Multiplatform plugin. So here in your Android Studio, go to this setting, and here on the left side you will get the tab with the name plugins. And here is the Kotlin Multiplatform plugin from the JetBrains. This plugin is showing in my install tab because I already have installed it. If you have not, then you can simply go to this marketplace and search for the Kotlin multi-platform here. And once you get this, you can just click on the install button. So after installing this plugin, we will create a new project. For that, first let's close it. We need to go to this Google, type this KMP wizard, and here on this first link we have this Kotlin multi-platform wizard. This will help us in creating the new project template. So here we need to name our project and we can name it whiteboard. And next thing, we need to provide this project ID. You can choose whatever you want. There is no restriction to this. And next thing, we need to select the platforms we need to target. So here we will target this Android with Compose multi-platform for UI, and we are not going to use for this iOS, so let's uncheck it. And next we have this desktop, and again this will use this Compose multi-platform for UI, and web we can see it is still in alpha. So after selecting this Android and this desktop, we can click on this download, and it will download us this zip file. So you need to unzip this file and open it in the Android Studio. So here I have opened it. First thing, we need to understand how this KMP project is structured. Here first thing, let's change this to project view. Here first, these three folders are not useful, and next we have this with the name Compose app, and next we have this source, and here we have these three directories. First one is specific to this Android, and last one is specific to this desktop. And in the first one we have this directory with the name Kotlin, and we have one file with the name main activity, And next we have this file with the name platform Android KT. So this is the code which comes with the new project. We will delete this, but first thing here we have this main activity file, and this we already know is the entry point of the Android application. From here the Android starts reading the code. And now next let's look into this desktop directory, and again we have two files for this. First one is this for platform, and this also we will delete, but first let's close this and open this main.kt file, and this is the entry point of this desktop application. From here the desktop app will start reading the code, and in between of these two things, Android and desktop, we have a package with the name common main. And first package we have this compose resource. Here we keep the resources like images, icons, strings value, like these. And next we have this Kotlin package for keeping the code. And again we have a file with the name platform, and here we have defined this expect function and this interface. Let's just close it for now. And next we have this file with the name greeting. Here this is just a simple class with a function greet. And next we have this app. This composable function comes with the new project. We can press Ctrl B. This function we are using in the main activity, from where the Android application start reading the code, and this main.kt file from where the desktop application will start reading the code. And we can select this main.kt file, and here is our app composable function. And in the same way we can see in our main activity also we are using this function. Now next thing, let's minimize this compose app package, and next we have this Gradle package, and here we have this version catalog file, and here we are defining the versions of different libraries and frameworks. And I think you already are familiar with this file. And next thing, we have two Gradle files. First we have this file with the name build.gradle. This is a project level Gradle file. Here we define all the plugins we will use in this application. Next, in our compose app package, we have another file with the same name build.gradle.kts. But this file is specific to this module. This project has just one module, that's why we have this single file. If this project were multi-modular, then we will have the multiple module level Gradle file. And here first thing we are defining the plugins which are specific to this module. And after this we have this Kotlin block. Here first we are defining that this project is targeting the Android. And for compiling the code we are going to use this 𝒗𝒊𝘆𝗹𝗆. And next here we have specified that we are going to target for desktop also. And next we have this source set block. Here we defined all the dependencies we need in our project, and this block has the dependencies specific to the Android, and this block has the dependencies specific to the desktop, and this block has all the dependencies which are common to both the platform. And after this we have this Android block. Here we are specifying all the things we need to specify which are specific to the Android, like this compile SDK version and these versions. And next we have this desktop block. Here we have defined all the things which are specific to the desktop. Now next thing, go to this version catalog file, and here we are specifying the Android Gradle plugin version. So let's change it to 8.3.0. This version is the latest which are compatible for this KMP project. And sync the Gradle and close these files. Now first thing, let's run our Android app. And here is our Android app. So let's click on this click me button, and here it is greeting us. Let's turn off the dark mode. So our Android app is running. Now next thing, let's run our desktop app. For that we have this main.kt file, and this is the entry point for this desktop application. So let's click on this run button and minimize it, and it is saying that it cannot load this file. This is the general error, but we can run our desktop app through the terminal. So here let's type this dot slash /gradlew space and run and press enter. And here we have a desktop app. Let's click on this click me button, and we have a UI with this compose hello Java version. And our app is working on both the platforms, Android and desktop. Now next thing, we will take all the code from the GitHub repository, whatever code we have write until now, and we will make that usable for this Android and desktop. So let's go to our GitHub repository. First thing, let's go to this source package and this main and this resource and drawable. And here we have all these icons. So I will take all these icons and we will use these icons in our project. And here in our project we have this compose app package and this source package and this common main, and we have this compose resource, and in this we have this drawable package. So let's paste all those icons here, and we have all these icons, and close this. Now next thing, let's go to this app composable function, and in this composable function we can see here they have used this image composable function, and from this they are getting this compose multi-platform image which they have in this drawable file. Here we can see. Now if we want some other image instead of this image, and here we can see we are not getting those images which we have pasted in our drawable package. We are getting only this compose multi-platform image which was already there with the new project. So why it is so? In the Android project, what we do, we just simply give the reference of that image with the help of that r.drawable.image, whatever image we have. But here in this compose multi-platform project, we cannot just give simply the reference from that drawable package. Here this compose multi-platform is targeting multiple platforms. So what it do? Here it generates the code itself, and with that code it gives reference of that image to all the different platforms. And we can see that here just press Ctrl B on this compose multi-platform image, and we have this drawable file, and this file we can see it is in this generated resource package, and this is how this compose multi-platform generates the code for giving the reference of the image for different platform. So what we need to do here, we don't need to write this code. This will be generated by this compose multi-platform itself. What we need to do, once we paste all the icons and images in this drawable package, we need to just rebuild our project. So with the build, it will generate all the code for the image reference. Here it has rebuilt. So now let's try to get some other image. And we can see here we are getting all those images. And if we press Ctrl B on any of these images, and we can see it has generated all this code for all of our images to give the reference for different platform. And close this. Now again let's go to our GitHub repository. Next thing what we need to do, we need to go to this domain model and this drawing tool.kt file. So first we will add this file. You need to download this raw file like this, and we will take this file, and in our app first let's go to this Kotlin package, and here in our whiteboard package let's create one package with the name domain and then model. And in this package let's just paste that file. And first thing we need to change this package name, and next let's rename this value to simply resource. And now this won't be a simply integer value, rather this will be a drawable resource from this JetBrain composed resources. And these images we will get like res from this generated resources, and we need to import this image. So this is how we will get these images. I will do the same for all these images. And here it has imported all these images, and we can delete this import and minimize these imports, and we have this drawing tool enum class ready. Hey everyone, if you are finding this tutorial helpful, you will love my premium Udemy course where we will build Measuremate, a fitness app using Jetpack Compose. We go in depth on the Firebase authentication, Firestore, and more. Check out the course in the description and take your skills to the next level. See you there. Next thing, in our model package, I will paste the another file with that drawn path name, and we can import this, and let's also rename the package name. So our next file is also ready. Next thing, in our whiteboard package, let's create one more package with the name presentation. And in our presentation package, let's create one more package with the name whiteboard. This package will be having all the things related to this whiteboard screen. And here we need one more package with the name component. And in this component package, I will paste that drawable tool fab file. You can take all these files from the code we previously write. Here first thing again we need to change this package name, and let's import this drawable tool and open these imports first. And here we can see this is not recognizing this material3 library, and we have used these components from that material3 library. And if I import this floating action button, and we get the import from this simple material library, but we are going to use material3 for our project. So what we need to do, let's go to our build.gradle file module level, and here we have the common main dependencies, and we are using this material library. Here we simply need to swap this material with this material3. We will get the suggestion, this one, and sync our Gradle. And the Gradle has been synced. So let's close this. And now it has recognized this material3 library. Next thing, let's optimize the imports first and close these imports. And one more thing I need to explain is this painter resource. We are getting the error. This is because let's open the imports first, and here we can see this import is coming from this compose UI resource painter resource. But in our compose multi-platform project we use different painter resource because we are referencing those images differently. And we can see this is giving error because we have changed from material to material 3. But we don't need to do anything here because we will delete this code after some time. But let's open these imports and check this painter resource import. Here this painter resource is coming from that JetBrains compose resource and then painter resource. So again we need to delete this import and let's import this painter resource again. And this time we will select painter resource from the JetBrains, and we have this painter resource. Now we can minimize these imports and we need to give the resource ID. This will be this selected tool dot resource, and this resource we already have defined in that drawing tool enum class. Now close these files. And now our drawing tool fab file is also ready. Now we can close this file. Next, in our component package, I will paste another file of that top bar. Again, first let's change the package name and open these imports and delete these imports from the previous package. And we don't have this preview. For now, let's just remove these preview functions. And again we have this error from this painter resource, and again we are going to do the same thing, delete this one and import the new painter resource from the JetBrains, this one. And here we specify with this resource dot drawable. So here our top bar file is also ready. Now we can close these files also. Now next let's paste that drawing tool card file. Let's close this file. Next thing, let's paste those two files for that states and event. First let's open this state file and import these new package. And here we have the state file ready. Next let's do the same with this event file. Next let's paste the screen file. First we need to change the package name. Next let's import the top bar from the new package. Same with these, and also this drawing tool. And preview function we can delete. And we can optimize our imports. And here is our screen file ready with no error. Next, let's paste the view model. First thing, again we need to update the package name and import this drawing tool. and also this drawn path, and here is our view model with everything working fine. And here in our GitHub repository, let's go to this main activity first, and let's take out this code, and all this code we are going to use in our app file. First thing, let's import this material theme, and let's delete this code and optimize our imports and paste the code which we copied from that main activity. And here first let's import the scaffold and this modifier from our compose UI. This fill max size. So here we are not getting the import of this view model. What we need to do here, let's go to our version file, and we have a view model here. But here let's duplicate this dependency and add the compose also. And the group name will be the same, but the name of this dependency will be lifecycle view model compose. This one. And the version will also be the same. And next thing, let's add this dependency in our module label Gradle file. Here in our common main, duplicate this implementation and just add compose after it. And it will reference that new dependency we just added. So now let's sync our Gradle again. And our Gradle has been synced. So let's close this and this one also. Now we can get the import of this view model. Here we have this view model compose, and let's also import this collect as state. And here we have this collect as state from that compose lifecycle, and minimize these imports. And this app composable function we are using in both the entry point files of different platform. So first let's go to this main activity, and we can delete this preview function and optimize the imports. And let's also delete these files, this platform file and this greeting file, and move this app file in the presentation package. And now if we go to this main.kt file, here we need to import the app composable function again. And same, let's import in the main activity. Next, let's also delete this platform.android file from this Android main. And same let's do in our desktop main. Now first let's run our desktop app. Again this is showing the same error, and we can run our app from this Gradle. We need to type this /gradlew run. And here is our desktop app, and open our drawing tool card, and we can draw anything here, and also these shapes. And let's make it full window. So here is our app. It is working perfectly fine. Now we can run our Android app. For running the Android app, we can do two things. Either we can run from this main activity or we need to go to this run, edit configuration. Here right now this main.kt file is selected. And if we directly click on the run, so it will run the desktop app. But we need the Android app, so click on this run. Here the app has been crashed, so let's check the logcat and open the errors. And here we are getting this error, composition local, local lifecycle owner not present. So let me see what more I need to add. So I checked the code and searched on the internet. I got this question on the Stack Overflow, and this is the same issue we are also getting. So let's scroll down. And the suggested answer of this issue here, first we can upgrade this lifecycle version to this 2.8.3. Right now we are also using this 2.8.0. We can check in our version catalog file here. But when I upgraded to this 2.8.3 version, then this version was not available in this Compose multi-platform, because many a times the libraries which are compatible for this Compose multi-platform are fewer version behind the libraries which are for Android. So this solution we cannot adopt. But here they also have suggested a workaround. So let's go to this documentation, and we have this issue on our issue tracker. And here the suggested answer we have, first we can change this compose version to this 1.7 beta, and next we can add this composition local provider, and next we can also add this. So we are going to adopt this third solution. Let's copy this line and go to our main activity and this app composable function, and we are getting these state with this collect as state with lifecycle, and we have a lifecycle owner, and we can pass this. Now again let's run our Android app, and here is our app. Now let's draw something, and we are able to draw, and also the shapes. And let's also run our desktop app one more time. And here is our desktop app also, and we can draw anything here. And our both the apps are working perfectly fine. That wraps up today's video. We have make all the code usable for KMP. Now our app is running on both the desktop and Android. In the next video, we will implement the local database using the Room library, and also we will add the dependency injection using the Coin library. Both these libraries are available for Kotlin Multiplatform. If you are excited, make sure to like, comment and subscribe. And remember, if this video hits 50 likes or 50 comments, I will release the next part of this series. Thanks for watching, and I'll see you in the next one.